Okay, so today I'm going over polynomial inequalities, which is usually difficult for people just because it's so not something that they're used to doing. It's going to involve a lot of factoring. We may have to do some synthetic division, and you're going to be plugging in a lot of numbers and checking the signs of numbers. You're going to be doing what's called sign charts. So first, what exactly is a polynomial inequality? Well, it's just simply where you have a polynomial, f of x equals like x squared, x cubed, or something like that. And instead of having it equal to 0 so that you can solve, you have an inequality like it's less than 0, greater than, less than or equal to, greater than or equal to. And it may not even be 0 on the right. It could be like greater than 5 or something like that. So if it's going to be in some sort of form, that's what's called a polynomial inequality. So it's good to understand what these are asking for, especially in terms of a graph, because you can use a graph to check your answer. So f of x is essentially our y values, and so whenever you graph, that's, you're looking at the graph that you're looking at, so like the shape and all that. So if you have a less than, it's basically asking where is your graph under the x-axis, where are the values negative, because less than 0 is negative numbers. And if it's less than or equal to 0, it's saying, okay, where is it negative, or where is our graph equal to 0? So it could be below or on the x-axis. Likewise, if you have greater than, it's saying where are our y values positive? Where is our graph above the x-axis in the positive area? And if it's greater than or equal to, then we're looking for the positive values, and we're also looking for where it's equal to 0. So that's generally what we're looking at. You can think of it in terms of a graph, or you can think of it as your output values, your y values. So just to give you an idea of what this means, it's always good to kind of look at a graph and take a look at the graph and interpret it so that you understand what we're asking for here. So I've got one graph here, and we're going to go through all 4 of these. So first is f of x less than 0. So we're asking where are our y values below the x-axis. So we're looking at the y values. So here we're below, and then we're below in that area. Now the answer to something like this is not what are the y's, what are the output numbers. We're asking for what x, what are the x values where we are out, because we're solving for x when we solve an inequality. So we're looking for what values on the x-axis, and so you want to translate those portions onto the x-axis. So you're looking at what parts of the domain are, we're finding where we're below 0, where we're negative, and then we're saying, okay, what are the x values that are associated with that? So what parts of the domain are associated with that? So what I have here is I've basically graphed, I have a number line here, and our key points, we have -4 where it looks like we're changing, and then we've got 0, and then again at 1. And so if I was to graph this, my intervals look like this if I'm graphing on the number line. So this is going back to our linear inequalities and the graphing and what that means. Now we're not including 0 because it says it's less than 0. So any point where it's equal to 0, which is the transition points, those are not counted. So those are going to be parentheses. And those always face where we're shading. So I have 2 sections here where our graph is below 0, where we have negative values. And so we're going to give our answer as a union of these 2 sections. So we have -infinity to -4, union 0 to 1. So we union those together to indicate that we have 2 sections, and those are the sections where we are less than 0. Now for less than or equal to 0, it's the same thing. It's except that you're allowed to include those endpoints. But it basically will look the same just with brackets instead, because those are where it's equal to 0. So we just switch all of our parentheses to brackets, except those that have infinity involved, because you can't reach infinity. So that's where it's less than 0. So I'm going to erase my picture here. The next one we're asking for, where is it greater than 0? So I'm going to graph again with my highlighter. And our graph is above the x-axis at these parts. And I'm looking for where on the x is it above. So I'm above between -4 and 0. And then I'm above from 1 on. That's where my graph is above the x-axis. So we can draw another number line. Make sure I'm actually on my pen and not my highlighter. So I have a number line. And we still have these key points where we're equal to 0. So we've talked about last week with earlier this week. I guess technically that was sort of last week, since today's the start of Sunday. But we talked about finding zeros, those key points. So we're still using those 0 points. You can see where it crosses the x-axis, because those are our transition points between positive and negative values of the y. And in this case, we're looking for where it's above. So we're above between -4 and 0, and then again from 1 to infinity. And because it's greater than 0, we're not including our zeros, so we use parentheses. So when I convert this into an actual answer, I've got 2 sections. I've got -4 to 0, and then also from 1 to infinity. So those are the 2 areas where we're above the x-axis, and we're listing our answers in terms of x, because we're always solving for x. Then with a less than, or with a greater than or equal to, that means you can include your 0 points. So you just convert all of those to brackets, except for the one at infinity, because infinity is always a parenthesis. So when we're looking at these inequalities, we're asking where on our graph are we above 0, and where are we below 0 as far as the y values, but your answer is the x values for which that is true. So your answer is always going to be given in terms of the domain. But you're looking for in terms of, like, you're looking at where over the domain is my graph, my output, positive or negative. So answers in terms of domain x. So are there any questions so far? Yes, Tim.
Will there ever be a situation where they ask for y in integral notation, or will it just always be x regardless?
It will always be asking for the x.
Okay, good.
Are there other questions? Tim, you got another one?
No, just trying to click the button off and did it twice.
To undo it. Yeah, I undid it and you probably undid it at the same time. Anyone else have any questions? Okay. All right. So I'm going to move on to how we solve these algebraically, like with equations, because that's really what we're going to be focusing on. But I wanted to start with, just so you understand what that means on a graph, because that kind of, it helps make your other stuff make sense, because I'm just a visual person, so I like to know, I like to have some connection there. So the process for actually solving these, when you have like an actual equation, you've got several steps here. So first, you always have to have one side have 0. So it's the same thing when we're solving and we're trying to find zeros. Or like if you're trying to solve a quadratic, you always have one side equal to 0. So we're always going to have one side has to have 0. Otherwise, it doesn't work. So you do that, and then you factor. So these are the same steps that we've been doing with finding zeros. And you still find the zeros. So you're still setting each factor to 0, and then you solve for the variable. So these first 3 steps are just finding the zeros, which we've done before. So if it's a quadratic, you can use the quadratic formula if you want. If it's larger, you may have to do some synthetic division, but you're still finding the zeros of the polynomial for the first 3 steps. It's what you do after that where things get different, and that's where you set up what's called a sign chart. So the book actually shows 2 different ways to solve polynomial inequalities. It shows by doing like a true-false method, and then it shows a sign chart. I prefer the sign chart. The sign chart is what is used when you move on to calculus. So you have to take calculus, you're going to be making sign charts. So I always do the sign chart method. I think it's actually easier. So you set up a sign chart. It always starts by drawing a number line and marking where your zeros are. And then you're going to be drawing vertical lines, and you're either going to be using dashed lines or solid lines, depending on what your symbols are. So if you have like a less than or a greater than symbol, you're going to be drawing vertical lines that are dashed. But if it's less than or equal to or greater than or equal to, then you're going to draw a solid vertical line. And that's just to remind you whether that point is included or not. So if it's a solid line, then it's like, okay, I can include that point. If it's dashed, that point, that 0 is not included. Then you're going to create rows for each factor above the number line, and you're going to do the multiplication below the number line. So I'll show you what that looks like when we start doing this. So that's what your sign chart, the setup, looks like. And then you start plugging in numbers, and you're going to pick areas of the number line and plug in a number, and then you're just looking, is my output positive or is my output negative? Because that's what we care about. We're looking for our y values. Are we getting a positive or negative answer? So we don't care what the actual numbers are. We just want to know, is it positive or negative when I plug in an x value? So you do that, and you fill in each section of your sign chart. And then underneath, when you fill out everything on the top, you multiply your signs together to fill in the bottom. Because when we factor something, we have things that are multiplied together. So we're going to be multiplying our signs. So what you need to know is that if you have an even number of negative signs, you always get a positive result. And if you have an odd number of negative signs, you get a negative result. So knowing those rules can help you determine whether your final answer will be positive or negative. And then once you've created your chart, that's when you write your solution. So this will make much more sense once you see it go through, but I recommend when you're doing your homework, maybe just printing out this slide and then having it next to you so that you can see all the steps that we're going to go through. So I've got 5 examples that I'm going to be going through, basically trying to do a wide variety so you can see the process here. So I'm starting with a quadratic because those are the easiest ones. This one is actually something that we can factor. So I'm starting with something that we can factor because it's going to be quick. And this is, once again, why I say everybody needs to be really good at factoring, is because we factor all the time. So first, you need to make sure that one side of this is 0, which is, we've got it greater than or equal to 0. So that's good. And if it helps, you might want to remember, greater than or equal to 0, we are looking for positive numbers. So some people like to just kind of write a note for themselves there. So we're looking for positive numbers, just as a reminder. So first step is to factor. So we're going to factor or solve, but this factors. So this factors to, let's see, x minus 4, x plus 2. So I'm not going to go into details of how the factoring goes because the focus here is what we do with the inequality part. The factoring part, you can get your practice on your own. If you're lost on the factoring part, what I recommend doing is after the session, maybe when it comes out to, when I send out the recording, then you can spend some extra time and ask for how the factoring occurred. But for the most part, I'm not going to show that because I want to focus on what we do after that. So x squared minus 2x minus 8 factors to x minus 4 times x plus 2. So first step is factor. And then step 2 is to find the zeros. So you're going to set each factor equal to 0. So even though we have an inequality, we're going to temporarily treat it like it's an equation so that we can find the zeros. So we get 1 0 at 4 and another one at -2. So I'm going to mark those on my number line. So I have -2 and I have 4. And so I'm just going to mark where the positive and negative infinities are. So I don't care where 0 is on the number line. All I care about are the numbers that make the y value zeros. So I don't care about the number 0. I care about the zeros. So once we do that, then we need to set up the sign chart. So when we set up the sign chart, this is a greater than or equal to symbol. So that means we're going to have a solid line. So I'm going to draw just a solid line at my zeros to remind me that I'm going to be including these. So you can see that that splits the number line into 3 different sections. And so we're going to be trying 3 different x values. So it doesn't matter what x value you try, but maybe you want to try like -3 because it's less than -2. Whenever possible, try 0 or 1. So 0 is between -2 and 4, so that's a good number to try. And then maybe we'll try 5. So we're going to be plugging in those numbers, but I'm just writing them down. I'm picking a number that's in each section of the number line. I can pick any number I want as long as it's in between my zeros or on the other side of my zeros. But I just try to pick easy ones. So we kind of pick what numbers we're going to plug in. And now you can see on my chart, I've got factor above, and then multiplication below. So what I do is I just write down my factors, and it doesn't matter which order you write them. You can put them on the left or on the right, but so I just put those factors on top. So x plus 2 and x minus 4, and then underneath I'll be multiplying my signs together. So are there any questions so far on how I set up the sign chart, or where I put things, or why I put those things there? Okay. So once you've set that up, now you're going to be plugging in numbers. You're going to be plugging in these numbers that we picked, and you're going to plug it into your factors. So you're going to be using your calculator. You're going to basically be saying, okay, I'm going to plug this -3 into x plus 2, and then I'm also going to plug it into x minus 4. And then your output, you just care about whether you get a positive or negative out. And then you write the sign. So if I plug -3 into x plus 2, -3 plus 2 is -1. So that will give me a negative. So I just write a negative sign there. And if I plug -3 into x minus 4, I get -3 minus 4, which is -7. So that's also giving me a negative. And then I multiply those going down. A negative times a negative gives me a positive. So I'm going to write a positive underneath it. Then you're going to go into the middle, and I chose 0. So we're going to plug 0 in for x. And we're going to plug it into both factors. So 0 plus 2 is 2, which is positive. 0 minus 4 is -4, so we get a negative. and then a positive times a negative is a negative. So I write that multiplication underneath. On the right, I'm going to plug in 5. I can plug in any number that's larger than 4, but I just usually choose the next one up. So 5 plus 2 is 7, so that's positive. 5 minus 4 is 1, so that's also positive, and a positive times a positive gives me a positive. So now I filled in the sign chart. Are there any questions with how I filled in those signs? Okay, so once you fill that in, then your next step is to actually determine the solution. So we want positive numbers. So we're looking for the parts where our multiplication ended up being positive. So that means our solution on the number line are going to be these two outside areas. And then because I have solid lines here, I'm going to have brackets because I'm including those values. So now I can basically just read off my chart going from the left to right. So I've got negative infinity on the left to -2 with a bracket. So that's one area where we get positive results. So that's where it's greater than or equal to 0. And then I union with the next part, which is 4 to infinity. And that also is positive numbers. And so that would be your solution to this inequality. And if I were to graph the actual graph here, I'm going to just sketch it. You get, okay, I missed my 4. So if you were to graph the polynomial x squared minus 2x minus 8, that's what it's going to look like. And so the question is, where are we positive? So we are above the x-axis on either side, from negative infinity to -2 and 4 to infinity. So you can graph it and you can take a look at your graph to see, does that match? You know, did what I got from the sign chart, is that correct with what we see when we actually graph the polynomial? And it is correct, it matches here. Are there any questions? Okay, so move on to my next one here. So here we have x squared or less than 25. We don't have something equal to 0. We don't have a 0 on one side. So that's what we have to do first, is we have to make one side equal to 0 or less than 0 or whatever the symbol is. So I have to actually subtract 25 from both sides so that I have 0 on one side. So I have x squared minus 25 is less than 0. So you have to make sure you get 0. If you tried to solve this with square roots, it's going to cause some problems when you try to make the sign chart, because then you don't have factors. So you're going to want to make one side equal to 0. Now we're going to do the same thing, same steps. So this can factor, and this is a difference of two squares, so it factors to x minus 5x plus 5. So I factor, and then I find my zeros. So I set each of those factors equal to 0 and solve. And you get 5 and -5. Oops. And then from there is the sign chart. So I'm going to put -5 and 5. on my number line. I'm going to put my factors. So it doesn't matter where you write them. If you want, you can put them on the left here. Doesn't matter which order they're in. I'm just writing them down. And now I need to do my vertical lines. So this is a less than symbol. So less than means we're going to have a dotted or dashed line. So both of these, I'm going to put dashed lines because this means 0 is not included. And we are looking for, because it's less than 0, we want negatives. So we're going to be looking for negatives when we're looking at our final answer on the bottom. The last problem is greater than or equal to, so we wanted the positive values. Here we want the negative values. So now I'm going to plug in numbers, so I could always pick 0 whenever possible. So 0 is between -5 and 5. And then I usually just pick one number on either side of our zeros, so like -6 and 6 to plug those in. So I'm going to first plug into I'll start from left to right, -6 into the x plus 5. So -6 plus 5 is -1, so that's a negative. And then -6 minus 5 is -11. And then a negative times a negative is a positive. Now I'm going to plug in 0 for x. So that's going to give me a positive and a negative, and then those multiply to a negative. Because basically I can just ignore the x and I'm just looking at my numbers, 5, -5. Those multiply to a -25. Now I'm going to plug in 6. 6 plus 5 is 11, so that's positive. 6 minus 5 is 1, so that's positive. A positive times a positive is a positive. So you can see we have the same pattern that we did on the last chart. It's the same exact pattern, but in this case we want the negative value. We don't want the positive. So we're looking for the negative part because it's less than. So we are looking for inside here. That's the only part where it's negative. And then because we're not including the endpoints because it's less than, we use parentheses. So our solution is just for the negative part. And we don't have a union because we have only one section. So between -5 and 5, that's where our graph is under the x-axis or below. And if I graphed x squared minus 25, it's going to look very similar to the other one. And so we're looking for where it's below the x-axis, so that's between our two zeros, as opposed to if we're asking for where it's above and then be on either side of the zeros. Are there any questions? Okay. So now I'm going to move on from the quadratics and go into things with higher powers. So this is going to require a little more work when we're finding the zeros because the factoring process, you know, we don't have a rule for factoring something that's cubic. We may have to do synthetic division. So here we have a 3x cubed minus 3x less than 4x squared minus 4. So we need to get one side to 0. So I need to add 4 to both sides and also subtract the 4x squared from both sides. We need to get one side to be 0. And then I'm going to make sure I put these in order. My 3x cubed minus 4x squared minus 3x plus 4 is now less than 0. So I just have to move everything I could move it to the right side. I choose the left because that's traditionally what we do with inequalities. So I just moved everything to the left. Now we need to factor this. So this is something that we can factor by grouping. And that catches my eye because I notice that the coefficients are in a pattern. We have 3, 4, 3, and 4 if you ignore the negative signs. And I think, oh, if I try to group these, is it possible for me to factor this by grouping? So I'm going to try to group them in pairs and see if I can factor this by grouping, because if I can, then I don't have to do synthetic division. Most of the time, you don't get lucky and you don't get to use grouping when you have something like this. This is a special case where it just happens to work out. So my first group, I have 3x cubed minus 4x squared. So I can factor out an x squared, which gives me 3x minus 4. And then if there's a negative in your next group, I need to factor out a negative. I'm going to just factor out a negative 1, which gives me 3x minus 4. So now I have the same thing in parentheses, so that's my first pairing, 3x minus 4. And then what's in front is my second pairing, x squared minus 1. So I have 3x minus 4 times x squared minus 1 is less than 0. Now I still need to factor this quadratic, the x squared. This is a difference of two squares, so I can factor that. So we get 3x minus 4 times x minus 1 times x plus 1 is less than 0. So now I've factored and I need to find the zeros. So we have 3x minus 4 equal to 0, x minus 1 equal to 0, x plus 1 equal to 0. And then you solve. So our first 0 is 4/3. Our second one is 1. And our third one is negative 1. So I'm going to put these on our number line. So 4/3 is a little bit bigger than 1, so I need to put it a little bit bigger than 1 on my thing. So I've got actually 3 zeros here on my chart, or on what will be my chart. So now we have this less than, so it is going to be a dashed or dotted line. So I'm going to draw that on my chart. And because we have the 3 zeros, we now have 4 sections. So we've got to fill in for these 4 different sections on a number line and pick numbers. So I always pick 0 whenever possible. So 0 is between -1 and 1. And pick -2. Now this is where it gets tricky. So we got to pick a number between 1 and 4/3. So it's usually easier to convert your fraction to a decimal. So 4/3 is 1.3. So we need to have a number between 1 and 1.3. So it could be anything, but maybe we'll pick like 1.1. Or 1.33 repeating for 4/3, but roughly. So I'm going to just pick a number like 1.1. Now I need to pick a number greater than 4/3. 4/3 is 1.3 repeating. I'm going to pick 2. So whenever possible, I pick whole numbers. So I've got to plug in 4 different numbers here to make my chart. And so I'm going to start writing down my factors here. I have 3x minus 4, x minus 1, and x plus 1. So before I move on and start plugging in these numbers, I know that this chart's a little different than the ones we've seen before because there's more factors, so there's more zeros. Are there any questions? Okay. So now I'm going to start plugging in numbers. I'm going to start with -2, and I'm going to plug it into each of these. So -2 plus 1 is -1, so that gives me a negative. -2 minus 1 is -3, that's a negative. And then when I get the 3x plus 4, that's where I'm going to pull out a calculator. So if I plug -2 into there, that gives me -10, so that's a negative. So I've got 3 negatives here. An odd number of negative signs means a negative is the output when you multiply. Because a negative times a negative is a positive. Positive times a negative gives you another negative. So I have 3 negative signs. 3 is an odd number. My multiplication will give me a negative. So that's why I put a negative underneath. It helps. You can remind yourself that's the multiplication. So now I'm going to plug in 0. So that's anything that has x, I can ignore it. So I get a 1, which is positive, -1, which is negative, -4, which is negative. And here I have an even number of negative signs, so when those multiply, I'm going to get a positive. Now I need to plug in 1.1, so that's where having a calculator handy is, will help there. So if I plug 1.1 into x plus 1, that gives me 2.1, which is positive. Then 1.1 minus 1 is 0.1, which is also positive. Then I have to do 3 times 1.1, then minus 4. I get negative 0.7. So all I care is that that is negative. Here, I have 1 negative sign, so that's odd, so my multiplication will be negative. Now, I've got my last section here, which I'm going to plug in 2. So 2 plus 1 is 3, so that's positive. 2 minus 1 is 1, that's positive. 3 times 2 minus 4, that gives us 2, so that's positive. And then those are all positive, so the result of the multiplication will be positive. Are there any questions on that sign chart? Okay, so now we need to determine what we want, whether we're looking at the positives or the negatives. And here we're less than 0, so we're going to be looking for the negatives. So we've got 2 negative sections here. And then I'm going to graph those on the number line. And because of the dashed lines, we're going to use parentheses. So I'm going to actually write these above. So I've got from -infinity to -1 with a parenthesis because it's dashed. And when you have a gap, then you need to use your union symbol. And then we're between 1 and 4/3. 1 and 4/3. That also gave us negatives out. And then if you wanted to graph this, you can graph this in Desmos. And you would see that this would give you the same answer. If I try to graph it, I think it's going to be something like, I think the shape is going to look something like that. with, with that being your axis wherever and something like this. That is my guess on the shape based off of our sign chart, but you'd have to put it in a graphing calculator or Desmos to double check. But that is the estimation I'm getting based off of our chart. Are there any questions? Okay. So here's another one where we've got something that's x to the 4th. And this one, if I'm looking at it, I first see, okay, if I've got 4 terms, can I do grouping? I can't, because the first two I'd be factoring out of 4, and both of them, they have the same coefficient, so you'd have to have the same coefficient for the last two in order to get those to kind of factor the same, and they're not. So we can't factor this by grouping, which means we're going to have to go through the synthetic division process to factor this, to find the zeros. But the first thing we can do is factor out the greatest common factor, because there is a greatest common factor in front of, or in all of these, because I can factor out a -4 and an x. So that is what I'm going to first do, is factor out a -4x. So that leaves me x cubed minus x squared. And 64 divided by -4, so that's a -16x. And then 80 divided by -4 is a -20, so we get -20. So I first factored out the greatest common factor, and now we have something that's cubic. And I also cannot do grouping on that, so that's where we have to go through synthetic division. And that's where you have to start guessing on where you think your zeros are. So that means we're going to have to use the rational zero theorem. So P is the number of the coefficient, or the constant, so that's going to be 20. Q is what's in front of the highest term, which is our x cubed, which is 1. So our factors of P over Q, so we're just looking at 20 over 1, so just factors of 20. So we can divide 20 by 1, 2, 4, 5, 10, and 20. And then you can have the plus or minus versions of each of those. I'm going to just be lazy and put those in parentheses just to show that the plus or minus goes to all of those. So I need to do synthetic division on our x cube, on our cubic, and hopefully I can pick numbers that will give us zeros. So I'm going to set up my synthetic division. So I have a 1, -1, -16, and -20. And I always try to find, I always start with 1, because that's an easy number to plug in. So with the synthetic division, you have 1 times 1 is 1, and then 1 minus 1 is 0. Then I have 1 times 0, then I subtract 16. So that gives us a -16. And then 1 times -16, then minus 20, we get -36. So this is not a 0. If it's a 0, we would have gotten 0 at the bottom. But with my multiplication and adding with the synthetic division, it does not come out to 0. So let me try the number 2 and see if that works. So I'm going to use 2 times 1 and then minus 1. So that's 2 minus 1, which is 1. 2 times 1, then minus 16, we get -14. Then 2 times -14, then subtracting 20, I got -48. So I look at my two numbers here, they're getting more negative. So if I try like 4, I think I'm probably going to get even more negative, and I'm getting further away from 0. So I need to try something in the other direction, because trying these positive numbers is getting me farther away from 0. So let's try -1. So I'm going to plug -1 into and do my synthetic division. So -1 times 1 is -1 minus 1. We get -2. -1 times -2 is 2 minus 16. That gives us a, let me double check my math here. -1 minus 1, yep, 2 minus 16, -14. And then that gives us -1 times -14 is a positive 14 minus 20, we got negative 6. Okay. So we're getting closer to 0 because I went from 1 to negative 1 and I got negative 6. So maybe I want to try negative 2 here. And hopefully I'll find a 0. So negative 2 times 1 is negative 2 minus 1, so that's negative 3. Negative 2 times negative 3 is a positive 6. 6 minus 16, negative 10. Negative 2 times negative 10, that's 20. 20 minus 20 is 0. Okay, so I found one of our zeros, which is negative 2. So when I rewrite this, we have negative 4x in front, x plus 2 as one of the factors, because the factor is written with the opposite sign of the 0. And then I have x squared minus 3x minus 10 greater than or equal to 0. Now I have a quadratic in this factor, so now I need to keep going. I have negative 4x times x plus 2, and then I factor the x squared minus 3x minus 10, and that gives me x minus 5 times x plus 2 greater than or equal to 0. So when you have larger polynomials, it takes several steps to get to the factoring. You may have to do some synthetic division, some guessing and checking using your rational zero theorem to kind of narrow it down for you. So now I need to find all the zeros from here, where you set each of them equal to 0. So the negative 4x, when that's equal to 0, and you solve, you're going to get x equals 0. With x plus 2, that gives you x equals negative 2. X minus 5 gives you a 0 of 5. And then x plus 2 gives you another 0 of negative 2. So we have a repeated 0 here, which is fine. And I'm going to put these on my number line. I have a negative 2. I also have 0. And then I have 5. And we're looking for the multiplication here. And then I'm going to put in my factors, negative 4x, x plus 2, x minus 5, x plus 2. So we've got 4 factors here. And again, we're going to just count if we have positive or even or odd negative signs to kind of determine what the multiplication is going to look like. So we've got a greater than or equal to 0, so we're going to be looking for positives, and it's going to be solid lines. So I'm going to draw solid lines here. We're going to be including all of our endpoints because it's greater than or equal to. And now I need to pick numbers to plug in each of these sections. So I can plug in, say, negative 1. Nope, that's not where negative 1 is. Negative 1 between negative 2 and 0. I can plug in negative 3. I can plug in 1 and then maybe plug in 6. So now I'm going to start left to right, start plugging in numbers, plugging in my x values that I've chosen. So starting from negative 3 and then going from top to bottom. Negative 3 plus 2, that gives me negative 1, so that's negative. Negative 3 minus 5 is negative 8, so that's negative. Negative 3 plus 2, that's negative again. Negative 4 times negative 3 is a positive 12, so that's going to give me a positive there. I have an odd number of negative signs, so the multiplication will be resulting in a negative. Now, my next section, I'm going to plug in negative 1. Negative 1 plus 2 is 1, so that's positive. Negative 1 minus 5 is negative 6. Again, I have the same factor, x plus 2, so that's going to be the same. Then negative 4 times negative 1, that's positive. Odd number of negative signs, this is also negative. Now I need to plug in a number between 0 and 5, so I'm going to choose 1. So 1 plus 2 is 3, that's positive. 1 minus 5 is negative 4, that's negative. Don't need to write the number. 1 plus 2, again, that's positive. Negative 4 times 1, that is a negative 4, so that's negative. Two negatives make a positive, so our multiplication will be positive. Now I'm going to pick a number on the right. We're bigger than 5, so I have 6. And 6 plus 2 is 8, so that's positive. 6 minus 5 is 1, that's positive. 6 plus 2, again, that's positive. And negative 4 times 6 is negative 24, so that's going to be a negative. We have one negative sign, so we have negative when you multiply it. Any questions so far? Okay. So now I filled in my chart. You know, the more factors you have, the more complicated it gets, but it's still the same process, and we're looking for positive numbers. So we just have one section here that ended up being positive. So we have our only answer is between, oops, somehow my, oh my goodness, I don't know what is going on here. There we go. Somehow that got deleted and I was doing weird stuff. So let me try that highlight again. We want the numbers between 0 and 5 as our final answer. And these are brackets because we have the greater than or equal to. So our answer is from 0 to 5. That's where this big long polynomial has positive y values. That's where it's greater than or equal to 0. Any questions? All right. Now here I've got something that's already factored for us, and I picked this because I want to show you some shortcuts that you can do. And if you have repeated zeros, grouping them together in pairs can make it really nice, because anything that you square here is going to be positive. If you have things that are squared, a negative times a negative is a positive, and a positive times a positive is a positive. So for a trick, something like this, if you can group them in pairs, and so that means if I have something cubed, I can group it as a square and then have one left over. Anything that has an even exponent there is going to be positive all the time. All of your factors are going to be positive. So as far as our zeros go, we have only two zeros. We have 1 and negative 2. And then for our factors here, I can put x minus 1 squared, x plus 2 squared, and then I can have that extra x plus 2. Because there's 3 of them there, I can just put that above. So we've got greater than or equal to 0, so this is positive. And we're going to use solid lines. So I'm going to draw my solid lines. And I'm going to just pick my numbers to choose. So less than negative 2, I can do negative 3. I can try 0, and then I can try 2. Now for anything that's squared, that's automatically going to be positive, because any number that I plug in there when you square it is going to get a positive. So I can already fill those in as just positive all the time. So now I only need to plug into the x plus 2, and then I can determine my multiplication. So I've saved myself a lot of work here. So if I plug -3 into x plus 2, -3 plus 2 is a negative. So now I get an odd number of negatives. One negative means my result will be negative. If I plug in 0 to x plus 2, that's 2, so that's positive. All of those are going to be positive. And then if I plug 2 plus 2 is 4, that's positive. All of those are going to be positive. So now I've got my sign chart here. And we want all the numbers that are positive because it's greater than 0, greater or equal to 0. So when I combine this, this is what it looks like on my number line. Now we're allowed to equal 0, so that means that I can include 1, that second line that's in between, and I don't have to use a union here. I have 2 sections, but because I can include the number in between them, I can write it as 1. If this was dashed, then I wouldn't be able to include. I'd have to have these as 2 separate sections with a union because we can't include the number in between. But because I can include that value of 1, which is right here, I can write this as one single interval from -2 to infinity. So this is a kind of special case here. We had some shortcuts here. Are there any questions? Yeah, Tim.
Explain that one more time. Why you included it as just one interval?
Right. So this is because I'm allowed to put x equals 1 because it's a greater than or equal to. So if I wrote it as 2 intervals, let me just write this in a different color. I could have -2 to 1 with brackets because we have the solid lines, and then 1 to infinity. But if I'm including 1 and it's a bracket on either end, there's no, this basically means the same thing, that I have from 1 and then I'm starting again from 1 because those match. So I can just combine that as one interval. Now, if it wasn't a greater than or equal to, if it was just greater than, these would be parentheses. And then I can't do that because that's explicitly saying that 1 is not included. So I have to skip 1 and I have to keep them separate. But if you have the same number on either side and it's bracket, you can combine them. Does that make sense?
Yes.
Good. Are there other questions? I'll just label that says greater than if we had that. Okay, so last one here. I've got x squared minus 6x plus 12 less than or equal to 0. So this is a quadratic. This does not factor. Wait a minute. Nope, does not factor. I was trying to think. I'm like, is there a way I can make this work? Does not factor. So we have to use a quadratic formula. So quadratic formula here. So that's x equals -b plus or minus square root of b squared minus 4ac over 2a. So I need to start plugging in my numbers. So b is -6. So you still have that negative in front because it's -b. Plus or minus -6 squared minus 4 times 1, and then c is 12. And then in the denominator, we have 2 times 1. So I'm going to start simplifying this. -6, that's a +6. And then in the square roots, negative 6 squared is a positive 36. And then minus 4 times 1 times 12, that's going to be a negative 48. So we're subtracting 48. And we get 6 plus or minus. And here we're going to get an issue because 36 minus 48 is going to be negative. We get a negative underneath the square root. So that tells us that we're going to get imaginary numbers. And if you get an imaginary number, when you have something that you're trying to find, like you're trying to find on the graph, imaginary numbers aren't zeros, they're not x-intercepts, so they're not actually on the graph. And so this specifically tells us there's no x-intercepts, so there's no interval. And this tells us you must do this by graphing, because our solution is either going to be everything is above 0 or everything's below 0. So you have to graph this in order to determine the answer, because you don't have any spots where it crosses the x-axis. So your solution is either going to be all real numbers or no solution. And which one it is based off of graphing, or you can plug in a number. So when I graph this, now knowing how to graph things, I have the leading coefficient's positive, it's going to open up, it's quadratic, it's going to be a parabola. The y-intercept is 12, so it's going to look like this. So I'm looking at the graph here. So everything is greater than or equal to 0. But we want to know where we're less than or equal to 0. So on the graph, it's never less than 0. It's never equal to 0. Everything here is positive. So we have no solution. So we had no x-intercepts, so we had to do this by the graph. Now, if this had asked for, if it was greater than or equal to 0, then your solution would be all real numbers, because everywhere that graph is above the x-axis. So whether we got all real numbers or no solution depends on that inequality and whether it's greater than or less than. Any questions? Yes, Tim.
Explain it again, how it's all real numbers.
So it's all real numbers for that particular if it's greater than or equal to 0, because greater than or equal to 0 is where is it above the x-axis. And this graph is always above the x-axis. So if you're asking for it to be greater than or equal to 0, it's always greater than or equal to 0. It's always positive because it's always above the x-axis. So that's why in that would be all real numbers. The opposite of that, if it's asking where is it below, if it's never below, that's where we get no solution. Does that make sense?
Yes.
Awesome. Any other questions? This is my last example. All right, great. Thank you guys for coming. I really appreciate it. Hopefully this clarified some things for you. I know that this section in the book, it's kind of hard to, I think that doing the polynomial inequalities makes more sense when you see it worked out versus just trying to read the charts in the book and be like, where did they come up with these charts? So hopefully that this helped you and clarified things for you. So I will try to get this out today by this evening if possible. I have a few other live sessions for other classes that I'm doing, so I'll try to get this out quick. And thank you for joining me.